Okay, good morning, or is it afternoon now? Good afternoon, class. I are all to Mamu with Jarvis for grade 9, and we're still on our algebra experience, looking at the matter of word problem. Essentially, the main objective of word problems is to try to translate statements into mathematical, perhaps equation or expressions, as the case may be. Today, we'll be starting off with, we've done sum, we've done differences. And we said that when we talk about a sum, essentially we are talking about what? To add. And when we're talking about difference, we would mean to do what? Subtract. And we try to consider two types of differences. We said there's something we call positive difference, and there's something we call a negative difference. Today, we'll go straight ahead to look at the concept of product. So you're given a statement or a word problem and you are told products. What exactly are they talking about? So let's go to the word products. So we're going to make reference to some of our texts here. We have the New General Mathematics for grade 9 or JS3, and also we will be taking some excerpts from the most treasured essential maths for book 3, or what you may call JS3, grade 9 JS3, book 3, as the case may be. So what exactly are we going to be looking at? Now let's take some questions there, and I'll take one interesting one from this book. It says find the products. Find the products. So I'll write that on the board. So class activity. Find the product of 2 3/5 or 2 3/5, comma 1 2/13 and negative 0.5. So that's what we are told to look for. Now, to attempt this question, the word product means multiply the numbers given to you. If you look at this carefully, you're dealing with 3 numbers, 1, 2, and 3. To answer this question, I would usually recommend that you convert this to a fraction. So what is 0.5? I know that 0.5 is taken as 5/10, which will be reduced to the lowest term, which is something you've been taught before now, and that will be 1/2. So if I say negative 0.5, I would expect you to have negative half there. This is the first thing you need to take care of. Once that is settled, you go straight away to now see what? 2 3/5 times 1 2/13 times negative 1/2. But that's not all. Remember that in arithmetic, we have a basic rule, and the basic rule is this. To multiply, we multiply in what is called the improper mode. Write that on the board there, improper mode. Improper mode. It means improper mode will mean that every mixed number I see, I must convert to what? Improper fraction. That also applies for division also. But when you are adding and subtracting fractions, we do that in what is called the mixed mode. So the mixed mode applies to addition and subtraction, and the improper mode will apply to multiplication or division. It's important you remember this very, very well to help you when you encounter problems like this. Now, this is the way mathematics works. We may be treating a particular matter and we'll always need to make reference to some other ideas. And that's the reason why we here as MAMU, we try to give you mathematics from 3 clear perspectives and try to show you how these perspectives are connected. And don't forget our slogan, our latest slogan, it goes this: every problem ends in arithmetic. Every problem ends in arithmetic. So if you have played with your arithmetic before now, you would want to pay close attention to what we're doing now. Alright, so that said, this will give us what? 13 over 5. How did I get that? 2 times 5 plus 3 times, this will give me what? 15 over 13. How did I get that? 13 times 1 will give me what? 13 plus 2, that will give me what? 15 times negative 1 over 2. Now, remember from our concept of whole numbers or exploring numbers based on the grade I'm considering, whenever you see a negative and a positive and they are multiplying or you have multiplied them, your answer will always be what? Negative. So I have a code I use for this. I would advise you do sign before number. Sign before number. And since we're treating algebra, we go with the code sign, number, letter. Alright, that sign, number, letter. So it tells you where you should lay emphasis. The problem we have is only dealing with what? Numbers and signs. So this is positive times positive, that will give me positive, times a negative, that will be what? Negative. Deal with that first. So that will be negative. And then the next thing, you apply your knowledge of reduction. 13 can cancel 13 here. 5, 1 here. 5 will give you what? 3 here. So that will be negative 3. That will be 3 and that will be 2. So that negative what? 3 over 2. Which you may or may not write as what? Negative what? 1 over 2. Negative one whole number, 1 over 2. So that's the solution to question number 1 in a matter of finding the products of what? These three numbers given to us. Okay, let's look at a question we have on the board. The product of two numbers is 54. If one of the numbers is 27, find the other. Product of two numbers is 54. If one of the numbers is 27, find the other number. Now, there are two ways you can solve a question like this. There's what I call sometimes I call it the OBJ approach. And then there's what I call the theory approach. Now, in the OBJ approach, I have two numbers. I know one, and I'm giving the other one. The answer, when I multiply the two numbers, the answer will always be bigger than any one of the other numbers I'm considering. The answer will always be bigger than any of the other two numbers I'm considering. So it means that to get the other number I'm looking for, I just need to say what? 54 over 27. And that answer will be 2. That's what I call the OBJ approach. But when it comes to theory, especially for NECO exams in theory, you can't do that. You have to now go to using what I call the theory or the algebra approach. How does it go? I will say, let the other number be x. Let the other number be what? X. Such that 27 times x will be equal to what? 54. And if I multiply a number times a letter, the answer is what? A number letter. If I multiply a letter with a number, the answer will still be a number letter. Because in writing, we write in the order of what? Number letter. So this will give me 27x equal to 54. I will just graciously divide both sides by 27. And if you do your arithmetic right, remember I said that everything ends in what? Arithmetic. If I do my arithmetic right, my final answer will be what? 2. So the other number is what? 2. So you see that in an OBJ exam, you don't need to do this. Mentally, you should. That's why when we prepare you for exam, we teach you to couple to keep yourself abreast with methods that can help you get your answer quickly. So you look at this. Okay, the two numbers are multiplying. One is 27. The answer is 54. Answer of our 1 I know. I say that answer of our what? 1 I know. So 54 over 27 will now give me what? 2. And if I multiply the 2, I'll get the answer. I see that. So that answers this one. So you see that in an exam setup, you don't need to waste time here. in less than 30 seconds, you get your answer and move on. Alright. Okay, so in trying to solve this question, we are well aware that we have what? 3 numbers. So here again, you can use your OBJ approach. You can also use your theory approach. Depends on what part of the, what type of exam setup you're answering this question. But I will go straight away to use the theory approach so that you can look at that and come up with what may be your best OBJ approach. So look at this. I'll simply say let the third number be x. Here I'm trying to introduce you to the concept of translating statements to words, mathematical words and statements as it were. Now, it means that the first number is 0.7 times 0.2 times x, and that will be equal to what? 0.084. Now, to get the other number, there must be some form of division. To get the third number, there must be a form of what? Division. To be what? What the final answer is divided by the product of the first and the second number. So, what I'm looking for, now sometimes you don't need to always rule. Sometimes keep some of these things you're doing mentally here. This will be equal to, this is the number I'm told to look for. Or this is the number I'm told the answer will be. Divided by the two numbers I know. And that will be what? 0.7 times 0.2. So, how do you take care of this? Remember that we have taught you what? Decimals. We taught you what? Decimals. Now, there's a technique I need to teach you here. If you look at this number, we have 3 decimal places. Here we have 2 decimal places accounted for. 1, 2. If you look at this, 1, 2, 3. The number of decimal places that can help us force out the whole number. So, because there are 3 places here and there are 2 places here, I need to use the highest, which is what? 3. So, if I move 3 decimal places here, I will have what? 84. If I move 3 decimal places here, I will have 1, 2, and an extra one that I have not used. So that will be what? 7 times 2 times 10. So the next thing I do, I can now do what? Apply my knowledge of what? Factors. 2 here 1, 2 here 42. 7 here 1, 7 here 6, which will give me what? 6 over 10. And what is 6 over 10? Simply what? 0.6. Now, the question here is this. Why is my choice getting my answer in decimal, not in fraction? The reason is that the other numbers you have been given, the first and the second numbers you have been given are in what? Decimal. So, by way of common sense, it will be best to keep the last answer also in decimal or as a decimal. Okay, so we've been able to look at products, looking at sample questions of how product works. Now, the next important thing we'll try to look at is to see how we can combine products to sum and difference, because that is what the real thing is. How do you solve a question having what? Product, sum, and